Hi students, this is Mr. Yao. In this lesson, we are going to talk about 8.4a, where we will actually mix together all the conic sections and learn how to be able to tell them apart. So first, let's review all the equations that we have learned. These are just the general form of the equations. Some things I would like to emphasize on would be if you have a look, all of them have the x minus h square and the y minus k square for the ellipse, circle, and hyperbola because they kind of do look similar in a way. Parabola is the only one that's different, but they still have the y minus k and x minus h, just not both of them are going to be squared. And for the ellipse and hyperbola, they're very similar. The only difference is a sign in the middle. One is a plus, the other is a minus. They are being divided by different things, and based on these numbers they're being divided by, the a squared and the b squared, is going to change the orientation of the whole graph. Meaning it's going to change where the major axis is and where the minor axis is. So have a look. These are the equations we have learned, and we are going to talk about the features. And after you have written down these equations. Now here's more. Here's when things are kind of oriented vertically, when the a squared is under the y minus k squared. Then that means they are going to be oriented differently. For the parabola, this is basically x equals y squared. We have learned y equals x squared is going to be facing up and down. Then, of course, x equals y squared is going to be facing left and right. So now let's move on to talk about the features. Circle and ellipse. So first, circles. The set of points on a plane that are equal distance from a given point. That given point is going to be the h. Okay. So when you are given an equation, you are going to write them in the standard form. So x minus h squared plus y minus k squared equals r squared. In this case, we're not going to keep the right side as a 1 because we do need to know what the r squared is. So there is no number in front of the x minus h or the y minus k. And things to identify are h and k as the center and the radius, which is the r, which is the number on the right side being square rooted. That's a circle, not much to identify. Moving on, ellipse. The set of points on a plane whose distances to two fixed points add up to the same value. So for all of these, the circle, ellipse, and hyperbola, my suggestion would always be identify center first. Always find the center first. So in this case, let's say our center is going to be the HK. I'm going to kind of draw my major axis and my minor axis. Since the major axes are actually horizontal, that means this is going to be x minus h squared over a squared plus y minus k squared over b squared. The whole thing equals to a 1. So after I know the h and k, I would need to actually go left and right for the a and up and down for the b. So even though I'm going to write down some letter representations for the points, please do not memorize these. Use the center and the a and the b to find out about the coordinates of these vertices and co-vertices. So this portion would be my a because that's my major axis. So that means the vertices would be from h left by a and right by a. So that's why I have the point as h minus a to the left, then k. And the one on the right is h plus a, and then k. And same thing from the center, I can go up and down, but this time I'm going to go up and down by a b. So the major axis will always have the length of a, the minor axis will always have the length of a b. So in this case, I'm going up b from the k. That means h stayed the same, but I have k plus b, then the other one is h, then k minus b. These are my co-vertices. So the major axis length would be 2a, minor axis length would be 2b, and the distance sum would be 2a. And I just identified my vertices and co-vertices. Lastly, I just need my foci. Foci will be on my major axis. So foci will be c away from my center. That gives my coordinate as h minus c then k, and h plus c, then k. As for how to find a c, you can clearly see that c is shorter than a in an ellipse. So in this case, c squared is a squared minus b squared. That's an ellipse. Moving on to hyperbola. Hyperbola actually has the most stuff for us to identify. So let's have a look. First, we are still going to have the center. Let's pretend the center is not 0, 0. Let's pretend these are not the xy axis. So that means my center would be hk. So I have my equation as x minus h squared over a squared minus y minus b squared, y minus k squared, not b squared, y minus k squared over b squared equals to 1. So in this case, let's start with my vertices right here. So that means that's my A and that's my A. So I can still write them in the exact same way as the ellipse. H minus A, then K. And this is H plus A, and then K. So these are my vertices. Next, my co-vertices. So up, let's say up B and down B. So, well, that's B, and that portion is also a B. So that means my point is going to be H, then K plus B, and H, K minus B. And remember, for hyperbola, since we have something called asymptotes, that's the only extra compared to ellipse. We are going to need to generate this rectangle, this box generated by the 2A and the 2B. So we have this box, which would give us our asymptotes. So I'm going to connect the diagonals. Technically, you need to draw them in solid lines, but I'm just drawing them in solid lines to be a bit clearer. Now, I need to find the slope of those, but before that, let's also identify our foci. So foci is still going to be C away from my center. That part is C. But this time, you can clearly see that C is longer than A. So C squared is actually going to be A squared plus B squared in this case. Not minus. Let me confirm. Yep, the previous one I wrote it right. Okay, C squared equals A squared plus B squared. And that means my point is still going to be H minus C, then K, and H plus C, then K. Lastly, I am going to write my asymptotes. My asymptotes will be y minus k equals plus minus b over a times x minus h. The asymptote, you can use this little triangle here to help you to identify the slopes. Because that part is going to be a b, that part is an a, so the slope is for sure going to be b over a. And of course, we have one to the left, one to the up left, and one to the up right. That's why we have a plus and minus b over a. As for the rest, y minus k is right here. X minus h is right here. So we can just use our equation to identify the other part of the equation for the asymptotes. So I'm going to point that from the asymptote. So that's a hyperbola. It's not a circle, a hyperbola. And lastly, we have parabola. For parabola, there are not many things we need to identify. To begin with, there is no center. But since this is facing left and right, you should automatically know it's going to be 4p times x minus h equals to y minus k squared. It's the y that's going to have the square, the x does not, because it's facing left and right. Now, to begin with our vertex, same thing, let's pretend it's actually not on any axis. That means this point is going to be h, k. And then for a parabola, something different is we have a p. P represents the focus, the distance between the focus and the vertex, and distance between the directrix and the vertex. So my directrix, and since this distance is a p, and that's hk, my focus would be h plus p, then k. My directrix would be x equals h minus p. Opening direction. If p is greater than 0 in this graph, it's going to the right. If p is less than 0, it's going to be opening to the left. So that's parabola. Now let's have a look at these things in some examples. But before we do that, let's actually find out a quick way to identify things. If you only have one squared variable, meaning you have, say, like, it's gotta be look like 4p times x minus h equals y minus k squared. You see y is being squared, or you can have 4p times y minus k equals x minus h squared, only x being squared. That's going to be a parabola. If only one of the variable is being squared, then it's got to be a parabola. If two of them are squared, if they have the same sign, for example, x squared over x squared, let's say 2x squared, 2y squared equals like 12. Well, they have the same sign, meaning they're both positive. They have the same coefficient, they're both 2. That's going to be a circle. They have same sign but different coefficient. Let's say you have like a 4x squared plus a 9y squared equals 36. They are both positive, but one is the 4, the other is the 9. That's going to be an ellipse. You have, say, like 4x squared, but this time it's not plus, it's minus 9y squared equals 36. You see they don't even have the same sign. That means it's going to be a hyperbola. So just based on the equation that you're given, without even solving for anything, you should be able to identify what kind of shape you're going to get. Now let's go talk about example 1 and 2. So first one, when we want to identify, we still need to move everything to one side. We're going to have 2x squared plus 12y plus 14 equals 2, negative 2y squared plus 2y squared, moving it to the left, and then minus 8x, that equals to a 0. Let's see, 2x squared and 2y squared, both are being squared, and they have the same sign, they're both positive. They also have the same coefficient, they're both 2, so that is going to be a circle. Now, let's see. We now need to actually rewrite the equation into standard form. That means we need to group all the x together, all the y's together, and leave the numbers on the right side. So 2x squared, we have a minus 8x, leave a blank. Well, we can actually leave the blank in the next step. And then plus 2y squared plus 12y. To the right side, the number is going to be a negative 14. In order for us to actually complete a square, we need to move the coefficient out. Because with an x squared, it's easier to figure out what is the square root and everything. So we are going to need to factor out the 2. We have x squared minus 4x, then a blank, then plus factor out the 2, so y squared plus 6y, then a blank, equals to negative 14. Since we have 2 blanks on the left side, we're going to also put 2 blanks on the right side. First, the number we need in the first blank is going to be negative 4 divided by 2, then squared, which is a 4. But to balance it on the right side, it's not just a 4. Since we have factored out a 2, it's going to be a 2 times 4, so an 8. For the second blank, 6 over 2 then squared is going to be a 9, so plus 9. But we need to balance it by adding an 18 because it's 2 times 9 on the right side. So we would have 2 times x minus 2 squared plus 2 times y plus 3 squared equals to, the right side is going to be negative 14 plus 26, which is a 12. But we already know it's a circle, so we can't have a 2 in front of x or the y. So next we're going to divide everything by the 2. So we have x minus 2 squared plus y plus 3 squared equals to 6. That means my center is going to be 2 negative 3, and my r is going to be a square root of 6. So 2 negative 3 right here. As for the r, square root of 6 is like 2 point something. I'm not going to ask you to find the exact number, so kind of just estimate it's going to be slightly over 2. So I can kind of draw my circle. It's not going to be precise, but at least it is a circle that we can draw. So there it is. There's my circle. That's example 1. For circle, you only need to identify the center and the radius. Example 2. So let's first have a look. For x squared, for negative 49y squared. Both x and y are squared, but they are different signs. So that is going to be a hyperbola. Start with the center by completing the square. Since everything's kind of already together, you can jump right to the completing the square step, meaning factor out the coefficients. We have x squared, and that is a negative 24x, so it's got to be a minus 6x. Leave a blank. And then the y is something you got to be careful with. This is a negative 49y, so I'm going to factor out a negative 49, leave the y squared. But since I factor out a negative 49, this negative 196y would also need to factor out a negative 49, leaving a plus 4y. And I'm going to move the number to the right side. So 356, but I have two blanks. Inside the first blank, it is going to be a 9, negative 6 divided by 2, then squared. So I'm going to need to add a 36 on the right side to balance it. 4 times 9. For the y, it's going to be a 4 over 2, then squared is a 2. It's a 4. But on the right side, I need a 4 times negative 46 to balance it, so minus 196. Next, I would get 4 times x minus 3 squared minus 49 times y plus 2 squared. On the right side is going to be a positive 196. Since it is a hyperbola, that means we need the right side to be a 1 so that we can identify the a squared and the b squared. So we are going to divide everything by 196. We have x minus 3 squared over 49. Then y plus 2 squared over a 4. That is going to equal to a 1. So in this case, my center is going to be 3, negative 2. That's my center. My A is under 49, so I can easily identify my A being a 7 and my B being a 2. And my major axis is going to be on the x direction. So from the center, I'm going to go to the right 7 and go to the left 7 as well. These are my vertices. I can start writing my vertices. I'm actually going to write it on the top, so I have more space later. Or actually, right here, vertices. 2 points we have negative 3, negative 2, and 10, negative 2. So that's the vertex. These are the vertices. Next, I'm going to identify my co-vertices. So it's since B is 2, I'm going to go up 2 and down 2. So co-vertices would be a 4, 0, and a 4, negative 4. I can also identify my focus, which is going to be slightly different. So since my A is 7, my B is 2, C squared is square root of A squared plus B squared. C squared is A squared, which is 49, plus B squared, 4. That means my C is going to be a square root of 53. But remember, you gotta count it from the center. So the center is at, wait, I just realized I graphed it wrong. My center is actually at 3. Oh, my bad. My center is actually at 3. I will change these. My center is at 3, negative 2. I will change my co-vertices to be 3s, 0, and 3, negative 4. And counting to the right by 7 is still going to be giving a 10. But counting to the left, but the point's wrong, it should be at a negative 4, negative 2. So this should be a negative 4. Okay. Now let's actually go with the foci. You got to start from the center, and square root of 53 is slightly over 7. So left by slightly over 7 and right by slightly over 7. These are my foci. When you actually want to write them down, your foci would be 3 minus square root of 53, negative 2, and 3 plus square root of 53, then negative 2. You got to count from the center. Now I can actually draw my box. My box is going to be right here from my A's and my B's. I can connect the diagonal and my actual hyperbola is going to be within the asymptotes, but still include the focus inside, and still include the focus inside. Now my asymptotes, I'm going to lastly write my asymptotes. It's going to be y plus 2 equals, my b is 2, my c a is 7, so plus minus 2 over 7, x minus 3. That's my asymptote. We are just going to use that center point to actually generate the point slope form. Again, the slope is b over a. So hyperbola has the most stuff, and that is example 2. Moving on, example 3. This time you can see only y is being squared. That means it is going to be a parabola. So now we need to start rewriting things. For a parabola, things are going to be slightly different. So let's get going. We still need the numbers to be on the left side. So x minus, plus 17. On the right side, I can factor out my negative 2. Then we have y squared plus, not plus, minus, because I have factored out the negative 2. That would also change the sign for the plus 12. It's going to become a minus 6y. Then we need a blank. The blank that we need to put in is a 9. And since we have put in a 9, we need to balance it on the left side as negative 2 times 9. So we need to subtract 18 on the left side. That leaves us with x minus 1 equals negative 2 times y minus 3 squared. But remember, the equation is actually going to be x minus h, but has a 4p in the front. And then on the right side is just y minus k squared. So I now need to divide everything by a negative 2. So I have negative 1/2 times x minus 1 equals y minus 3 squared. If my 4p is negative 1/2, that means my actual p is going to be negative 1/8. That's going to be hard to draw, but it is kind of the idea. So my center, well, not my center, my vertex is going to be 1, 3, right here. My focus is going to be, I'm actually going to choose to not draw another graph because it's actually too crowded. So my center is at 1, 3, and to the right, because my p is, actually to the left, my p is negative. Since my p is negative, so I need to go to the left to get the focus. This little portion is, the length is 1/8. That means my focus is going to be at 7/8 and 3. But my direction is going to be to the right by 1/8. And then my direction is going to be x equals positive 9/8. And my graph is going to be opening to the left. That is my parabola for example 3. Lastly, example 4. Let's move everything to the same side first. 49y squared plus 33 plus 98y plus 16y, x squared equals 0. And clearly you can see the x squared and the y squared are on the same side and they're both positive, but they are different. They have different coefficients. I mean, this has to be ellipse. So let's start putting everything in the right format. 16x squared in the front. Then 49, I need to factor the y squared, the 49 out, so I only leave y squared. Then plus 98y becomes a plus 2y. I need the number to balance it. On the right side, I have a negative 33. Now it's time to make it balance. So the number I need to put in there is a plus 1. But the number on the right side is not going to be. So I'm actually going to erase that and move it to the bottom. That equals to negative 33, and we need a blank. The number that goes into the blank is going to be 1 times 49, which is a plus 49. So we have 16x squared plus 49 times y plus 1 squared equals to a 16. But remember, we need the right side to be a 1. So now we are actually going to divide everything by a 16. So we have x squared plus y plus 1 squared. This is where it's slightly tricky. It's going to be a 16 over 49 on the bottom. And on the right side, it is just a 1. Okay, now, next. I can have my center. My center is going to be at 0, 1, 0, negative 1. 0, negative 1 is right here. That's my center. And this is basically over a 1. So 1 is clearly bigger than the other one. That means my A is 1 and my B is going to be 4 over 7. This is probably not the best example. Everything is too crowded for us to draw. So I am just going to draw it on the top. So the center is at 0, negative 1. And I am going to move to the left by 1 for my vertices. My vertex is going to be at 0. No, not 0. It's going to be negative 1, negative 1. And to the right is going to be 1, negative 1. And then if I move up by 4, 7, that is going to give me 0 and negative 3, 7. And move to the bottom, 4, 7. That is going to give me 0 and negative 11 over 7. And there I actually have my whole ellipse. And you will be able to find out the focus and then move from the 0, negative 1 to get the focus. The focus in this case is slightly more complicated. So my C, remember, is going to be A squared minus B squared, my C squared. So in this case, it's going to be 1 minus 16 over 49. So it's going to be square root of 33 over 7 for my C. So that means this point is going to be negative square root of 33 over 7, negative 1. That point is going to be square root of 33 over 7 and a positive 1. So that is example 4. That is a bit more complicated. So if you didn't fully understand how to do the parabola, we'll go back to the previous lesson, to 8.3, and watch the last example. Then you should be able to get a better understanding. That is everything for 8.4a. Thank you.